So Charlie, speak on the importance of space exploration, not only to this generation, but future generations.
I, that's you ask a critical question because if we're going to spend the money that we spend on space, we need to know why. A point I would try to make to all of your listeners is anytime you're trying to make a decision about anything in your life, the number one question you should ask should be why. Why should I take this job? Why should I do this? Why should I invest in this? Ask yourself the why, first of all, so that you know what is it that's motivating me to do this thing? And we all should, as citizens and taxpayers in America, we should ask ourselves the question you just asked me, why space exploration? The most important why is because it helps us understand this planet on which we live so much better. When you get away from the planet and you can look back and you can see it the way that I had the opportunity to see it on my 4 space shuttle missions, the concept of our atmosphere and of an environment that protects this planet really comes into stark view because you see this thin blue line around our Earth, and it's like a shell that surrounds Earth, and it's really, I keep referring to it as a thin blue line. If you take your thumb, you're up there, and you turn your thumb sideways and close one eye, put your thumb up against the atmosphere, it goes away. That's how thin it is, and there's about 10,000 feet of it that contains enough oxygen to keep you and me alive. When you get above 10,000 feet, there's just not enough oxygen for human beings to survive. That's why in airplanes, if you go high enough, you have to have supplemental oxygen. People who jump out of airplanes, they wear oxygen until they get below 10,000 feet where there's enough oxygen to live. So one of the reasons we should go is to explore our planet from that vantage point so we can understand this environment in which we live much better. It really wakes one up to the importance of caring for the environment. You realize that we live on a single ocean. Earth is a water planet. 75% of our planet is water. And there are these bodies of land called continents or islands or different things that stick up occasionally in this water. But we live on a water planet. And when you look from the vantage point of space, the thing that you see 75% of the time when you're there is water. And you realize that we need to protect the oceans because whatever we do to one body of water eventually will work its way around the planet to everywhere. So we need to figure out how do we preserve our environment for the benefit of all humankind. We do lots of medical experiments, lots of biomedical experiments in space, and that's not only to protect astronauts and learn how to keep them safe and healthy while they travel to places like the moon and Mars, but more importantly, it's to try to use the vantage point of microgravity space where we can do and see a lot of things much more easily than you do here on Earth because gravity is taken out of the equation. So doing pharmaceuticals research, looking at materials processing, building really strong materials, those kinds of things can be done in space far more efficiently than they can down here on Earth because gravity is taken out of the equation and gravity doesn't mess things up. So you look at, everybody's familiar with vaccines, with COVID, everybody knows what a vaccine is. Vaccine development generally will go much quicker in space because again, we can look at the very basic makeup of the virus that we're trying to attack. And what vaccine scientists are trying to do is design something that will actually marry that virus. People talk about the spike protein of people are accustomed to seeing this circle, this little ball with all the spikes and stuff. If we can get a picture of that protein molecule and see how it's shaped, then scientists can build something that goes in and matches it and kills it for all intents and purposes, but makes it unable to attack the human body. And that kind of stuff is done much more efficiently and effectively when we're on microgravity environment of space. We're now using 3D printing, a process that you may be familiar with. I know a lot of the kids in your audience know it very well because they have 3D printers in their classrooms. But we have 3D printers on board the International Space Station today where we're developing technologies to build materials, whether they're components for satellites or components for rockets in space. So we take the feedstock, we take powder or strips of metal or plastic or whatever it is we want to build it with. We take that material with us to space. Takes a lot less energy than it does to take a completed rocket or a completed satellite. And we're going to build those particular things in space in the microgravity environment. using 3D printing and the like. So just a few examples of why we should do it.